Okay, so I'll start record a class. Yeah? Okay, ni jawab kat luar. Okay, so today, so untuk orang yang dalam apa benda ni online, boleh tengok my presentation. Okay, don't need untuk tengok through my camera, boleh tengok my presentation. I dah share. Alamak, internet hilang lagi ke? Guys. Macam-macam nama hotspot orang. Tambah siapa yang selalu duduk dekat DRB tu macam-macam saya nampak. Macam ni lah internet. Okay, hello. Wahai rakyat-rakyat online. Saya record tau. Alvin. Kenapa awak? Dengan kawan sebelah awak ni.
Boleh, sir.
George. Okay.
Tak apa, sir. Mereka nak hiburkan.
Okay. So, korang boleh dengar kan? So, let's masuk kelas. Okay. Wahai my donkey and my princess. Okay. So, today kita akan tengok on Le Chatelier principle. So, siapa sini yang pandai cakap French? Okay, tolong pronounce. Okay. Okay, bonjour mademoiselle. Okay, so here's this guy lah. So Louis Le Chatelier. So apa yang dia jumpa that apparently so any system yang ada equilibrium, which is kita denote as arrow yang separuh atas dan bawah, dia cakap if any changes that happen to the system, okay, the closed system, the system itself will try to establish equilibrium. Okay, so we have a few factors yang can affect the equilibrium. Okay, so this is okay, good. So we have dia cakap lah, is in a chemical system. So macam hari tu kita bincang pasal equilibrium, everything is in closed system, and any changes yang kita add, contohlah kita tambah NH3, kita add more ammonia, so apparently the system will start to shift back untuk jadi equilibrium balik lah. Okay, so dia akan start to reduce. Okay, blah 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 blah. Don't worry, kita akan explain one by one. Okay, so just untuk your macam mana ni ya? Sekejap. Display setting. Okay, keep. Right, still recording. So, dia masuk balik. Yo Allah, dia jadi balik. Oh, ada sini ya. Jangan. Duplicate check. Dah okay. Okay, so just imagine it is as you punya jongkang-jongkit or seesaw, right? So a perfectly balanced seesaw, okay, would want to be stabil lah kan? Want to be like this. Okay. So when you start adding stuff at one side, the seesaw will start to tilt to the heavier side. So Le Chatelier find out that this, contohlah you letak, okay, saya tak tahu nama korang, apa nama kau? Okay, contohlah kita letak Haris sebelah kiri. So Le Chatelier cakap Haris will start, tanpa dia punya kesedaran, akan start berjalan ke kanan untuk stabilkan balik. Okay, so same as chemical. Any perubahan, dia kalau boleh dia nak jadi balik stabil. So in equilibrium. So this is the graph. So don't worry, the graph will not be asked. Okay, it's just to show when you add something, it will start to change balik and it will start to achieve balik equilibrium. Okay, so kalau you tengok sini dah start, dia dah equilibrium. Why? Because the concentration dah tak change. Concentration dah keep constant. So once, contohnya now you tambah NH3, they will start to undergo the same process again to achieve equilibrium where the concentrations are constant. Right? So this is the ice table. Yesterday kita buat dengan kawan kita K1T1. Korang okay ke K1T2? Boleh buat ke ice table? Oh, kita nak buat kat depan. Senyap je semua. Cuba. Okay. So, ice table, walaupun ni banyak, just the same. The same thing, we have initial. Okay. So, and then we have the change, which is now dia tambah. Okay. But now, dia tambah kat here, becoming the new initial. Okay. So, ini the new initial, becoming the change. And then this is the new equilibrium. Okay. So don't worry. Nanti kita akan bincang a type of question yang macam ni. Okay. So we have 4 main factors yang kita affect equilibrium. Okay. So we will study about concentration, pressure and volume, temperature and the presence of catalyst. In experiment 5, we will look on concentration, pressure and volume not, kita akan tengok temperature. Okay, so ini nanti the type of question is, kalau you guys tengok tutorial, dia akan tanya and dia akan tanya what will happen. Okay, so this is very important, especially siapa yang nak jadi chemical engineer, siapa yang ada cita-cita jadi chemical engineer. This is sort of stuff yang you akan deal day by day. Contoh nak keep your power plant ataupun your chemical plant to run perfectly, okay, at optimally lah. Okay, so the type of question dia akan tanya kalau chapter 6 is, dia akan bagi contoh an equation and dia akan tanya bila dia ubah something, what will happen to other components of the equation. Okay, so contohnya PCl5. Okay, we are making PCl5 and that is, okay, QC, just remember, the same as KC, but KC is at equilibrium. At equilibrium. While QC is the reaction coefficient where this concentration are not at equilibrium. Tak kisahlah dekat start ke ataupun lepas any disturbance. Okay. So let's see an example where kita change the concentration of chlorine. Okay. So we add more chlorine gas. So what happened? Okay, we're having more chlorine gas on the left side. Now, what will happen is the system nak jadi balik equilibrium. Okay, so the system will start to produce more PCl5. Okay, so imagine here. Okay, so we have a seesaw. Hey, so we have a seesaw. Okay. So at equilibrium, sekarang dekat equilibrium dia ada PCl3 and Cl2. Kau nampak kan? And here is PCl5. But now we are increasing chlorine gas. They start to becoming tilting this way kan? Okay. The equilibrium punya system tak suka dia tilt. So dia nak jadi balik sama. So korang rasa dia buat apa? How nak buatkan sama balik? Yes, so we are increasing PCl5. So how the system are increasing PCl5? Okay, we are having more Cl2, so dia just react je lah dengan PCl3. So the added chlorine gas akan consume, and also PCl3 also akan decrease. So this is the thing yang kalau question tanya, the answer you should include. Okay, first is this. So as you are stating QC is less than KC. Okay, macam mana you tahu QC less ataupun more? Okay, you tulis dia punya equilibrium law hari tu kan? So KC is equal to product punya concentration ataupun partial pressure over reactant. Alright. So sekarang apa yang bertambah? Product ke reactant? So reactant bertambah. Okay. Kalau reactant bertambah, this value should be higher or lower? Yes, lower kan? Okay. So but now this is not KC lah, this is QC. Sebab it is not at equilibrium. Okay. KC is only constant dekat equilibrium. Right? So QC is lower than KC sebab kita tambah Cl2. So that's why it is lower. Okay. The second is you have to state this one, sorry. So this one is the reaction proceeding to left or right. Okay. General idea, general lah. Nanti kita akan tengok different factors lagi. General idea, kalau you add belah kiri, the reaction will go belah kanan. Kalau you add belah kanan, the reaction will go belah kiri. That's the general idea. Right? Okay. So and then the third point yang you have to add is you have to list down, okay, or you bagi tahu which one yang berkurang, which one yang bertambah. So in this case, you tambah Cl2. So what happen is more Cl2 and more PCl3 akan berkurang consume, while kita akan add more and more PCl5. Okay. So that one clear so far? Okay. That is you are explaining lah banyak the type of question. Right? So that's just the data. So don't worry. So what happen now kalau kita remove PCl5 pula? So the equation is at equilibrium. We have one Haris here, right? But now kita buang separuh Haris. So tinggal kepala dia je. Okay? So now belah sini dah jadi ringan. So this one will go up and this one will start going down. And dia nak destabilize balik. So what happened? So this is why we have a separate chapter about reversible reaction. Okay? Sebab not only going forward, we can also going backward. We will start using, okay, apa nama kau? Apa? Harrison. So Harrison ada luar sini. So apparently Harrison berat. Okay? So we will start using maybe kaki Harrison untuk buat balik Haris. Okay? So we will start to reuse the product yang kita dah ada untuk buat balik reactant. So this is what happened. Okay? So same thing lah. So kita remove dia, which is kita remove the bottom part of the fraction. So dia akan bertambah lah kan. So that's why QC akan jadi bigger than KC. So just remember KC akan stay constant, kita tak gerak. Right? So the thing yang you need to tell here, and then start proceeding to left. Sebab here kita dah kurangkan. So kita akan reaction akan start going this way. And PCl3, not only PCl3 akan increase, both of the thing akan increase. Okay? Tak kisahlah ada berapa banyak pun. So once the reaction going to that side, semua benda yang dekat situ akan bertambah. So once the reaction going to the left, everything yang ada dekat left akan bertambah including Cl2. Okay, so PCl5 berkurang. Okay, pretty self-explanatory. Okay. Okay, so this is just kalau like the same thing tapi dia ubah benda yang lain. Okay, cara nak cerita sama. Okay, so and this is also the same. I'm going quite fast here. Kalau apa-apa yang tak faham, bagi tahu. Right? So this is benda yang sama tapi in terms of question. So the question might ask macam ni lah. So this is a type of question. Okay, dia tanya and each of this will cost you 1 marks. So we will have 4 marks lah. And dia akan tanya kalau what happened to one side kalau kita tambah oxygen. Okay. So jawapannya increase lah sebab once you tambah oxygen, the reaction will start going this way. Right? Kalau this kurang H2S, kita kurangkan, the reaction will start going this way. Sebab dia nak achieve equilibrium balik. So, okay, this is a bit yang pening sikit. Okay, jangan worry, don't worry. Kita akan tengok one by one on pressure and volume. Okay. So, we have 3 things yang kita boleh buat. So, we can change the concentration untuk change the pressure, or kita add inert gas. Siapa tahu inert gas tu apa? Gases group 18. Or any gases yang tak react dengan kita punya reaction. So inert, it means it is unreactive. Okay, dia tak react at all. So dia tak affect langsung our reaction. Okay, so by that kita akan change the volume lah. So first, so this one is the one that you have to take note because we are no longer looking kalau tambah kanan dari dia pergi kiri, tambah kiri pergi kanan. Not anymore. We are looking at moles of gas. Okay, macam mana kita tengok moles of gas? Right? So, you are looking at stoichiometric punya moles. Okay, stoichiometric moles. Okay, apa tu stoichiometric moles? Is the moles yang depan sini. So, how we are looking into it is you totalkan the moles. So, belah kiri, so we have 2 items. So, each of this ada satu stoichiometric moles. Kan? So, saya tak tulis satu kan? This is a balance equation. So, we have 1 plus 1. So, belah kiri we have 2 moles of gas. And belah kanan we have 1 moles of gas. Okay. Untuk pressure, volume and temperature pun kita akan tengok moles of gas. Okay, sebab concentration senang. Kita tengok kalau kita tambah sini, dia akan terus berkurang situ. Okay. Kalau pressure, volume or temperature, kita tengok on moles of gas. Alright. So what happen is kalau volume to decrease, okay. Kalau volume decrease is gas pressure terus increase lah kan. Can you guys, any of you guys state what is pressure? Okay. Apakah pressure in a closed system? Saya menjadi tertekan dengan jawapan awak tu. Okay. Pressure is, yang kita calculate pressure is how many times the molecule hit the wall. Okay, berapa banyak kali molekul ni hits the wall, that is the pressure that we are feeling. Okay, you tutup tangan, you tiup, you rasa angin tu is the pressure of how many times that tak payah tiup, is how many times the air molecule hits your punya wall of hand. So that is the pressure. Okay, so bila you are decreasing the space ni dah jadi makin mengecil. Okay, the molecule have no way to go kan, so it will hit the wall even more frequent. So the pressure akan increase. So bila pressure increase, okay, yelah dia cakap sebab volume decrease lah pressure increase. Okay, so apa yang dia affect equilibrium? Kenapa dia nak pergi kiri ke kanan? Kita tak tahu. So what is happening now? Cara dia nak pergi balik equilibrium according to Le Chatelier is you punya reaction akan start moving towards yang lebih sikit mole. Okay, so bayangkanlah, so sekarang you have two components. So ada banyak lah, ada banyak. So pressure tinggi, kan? You dah decrease the volume, pressure dah tinggi. But now dia nak jadi balik equilibrium, which is like pressure tadi. Okay, dia nak rendahkan balik. So what happen is this molecule start to bercantum together balik. So which is dia akan pergi ke the less moles. So from higher mole dia akan pergi ke mole yang rendah. So that's why dia akan react ke mole yang rendah. Tak semesti dia pergi ke 1 mole kan. But some reaction ada 2 mole sini and 3 mole sini. Okay, so dia akan start pergi ke rendah. So the reaction will start going to the right. So PCl5 akan increase. Okay, is that clear so far? Okay. Nanti saya tanya soalan. Okay. So kalau biasa, so volume increase, pressure akan decrease lah kan. So you have more space, so the collision between the wall akan decrease lah. So that's why untuk dia stabilize balik, nak equilibrium balik, so it will start to create more molecules. Daripada sebiji-sebiji ni, dia create balik untuk jadi 2 biji. Right? Kenapa? Panas ke? Okay. Dah ni panas. Tapi kita sepatutnya buka tingkap. Tapi malas nak buka tingkap. Panas kan? Okay. So, this is the opposite explanation daripada tadi. Boleh ke? Semua okay ke? Okay. This is dia punya infographic. Okay. So when we reduce dia punya volume, the pressure akan increase. So the pressure akan increase. So the more molecule ni dia akan nak reduce balik the pressure, dia akan start to bercantum or dia akan start moving towards yang less mole. So less mole. Kalau pressure bertambah, okay, dia nak jadi balik, which is equilibrium je tadi, dia akan start to separate balik, dia akan move toward yang more moles. Okay. Moles. Okay, so bayangkan ini adalah equilibrium. Okay, ini bukannya bermaksud left or right I'm showing that dia akan move towards more moles. This one dia akan move toward less moles. Okay, tak semestinya more moles belah kiri, less moles belah kanan. Okay, we can have less moles belah kiri juga. Right? So, usually, nanti kalau you nak study tu exam, this is the slide yang you guys boleh tengok lah. So, slide yang take note ni. Terus, kalau you guys macam alamak tak faham lah, nak hafal pun tak apa. Okay? But if you want further understanding, you should lah, you should faham the reason why they start to move left or right. Okay. So look at this. So we have A, B, C, and D. Okay. The temperature is kept constant, which each of the reactants cylinder are fit with a movable piston. Alright. So what happen kalau A dia punya volume kita increase kan? Yes, pressure decrease, and then the reaction will go towards ke kiri ke kanan? Kiri kanan. Saya panggil nama. Defarge ada ke? Defarge. Untuk A, reaction pergi kiri ke kanan? Bila kita increasekan volume. So, volume kita increase, pressure kita decrease, kan? Dia nak balik ke equilibrium. They should kurangkan moles ke atau they should banyakkan moles? kiri, dia pergi ke kanan. Dia pergi ke kanan sebab dia nak banyakkan balik moles dia. Okay. So, question number 2, kita turunkan volume. So, pressure dia. So, the pressure will increase. Okay, the reaction will start to shift belah kiri or kanan. Kiri ke?
Kanan.
It will go to ke kanan. Kenapa? Terkejut. Okay, kenapa dia pergi ke kanan? Sebab dia nak...
Smaller ball.
Yes, we will have less moles. Okay? Dia nak pergi balik ke normal punya pressure. Okay. So, kalau ini pressure naik untuk C. Okay. Kalau C pressure naik. Okay. This one kita pressure naik. So volume kita akan turun. So what will happen? Dia ke kiri sebab solid. Okay? Solid tak ada pressure. So dia nak kurangkan pressure, dia tukarkan kepada solid balik. So dia kurangkan balik pressure tu. Okay. So you get the idea now? Okay.
Sir,
Yeah?
boleh tak ulang untuk C tadi?
C? Sangkut ke? Okay.
Tak faham.
So C. Alright. C contohlah saya bagi dia punya volume. Okay, kita bagi volume kita naik, right? So, volume kita naik, our pressure will go down, right? So, that is I think everyone know, volume naik, pressure turun. So now, bila pressure turun, we are having more molecules dekat each other. Okay? More molecules dekat each other. Okay? Dia nak jadi molekul. Okay, the system always, kalau boleh dia nak jadi equilibrium balik. So, molekul tu nak jauh-jauh balik. So, what will happen? Okay? Pressure rendah kan? Sorry. Salah ni. So, pressure rendah, molekul tu jauh-jauh dengan each other. Okay? Kalau boleh dia nak dekat balik. So, what will happen? The solid will start to turn into gas. Sebab kalau solid, they still are not affected by pressure. Solid have no pressure. Only gas have pressure. So the solid will start to turn back into gas. Okay? Ni awak terkejut sangat. Okay, nak jadi chemical engineer ke? Dia jadi apa? Okay, sorry. This is less relevant for you but still relevant for now. Masuk exam. Okay. So this kind of question you boleh buat, tak faham, boleh come and tanya. Right, so that's the answer. Okay, now the effect of inert gas. So inert gas, which is like group 18 tadi. Okay, bila kita tambah, it also changes the pressure without reacting with the original equation. Right? So, the equilibrium position are not affected, but we have two criteria here, dekat constant pressure and constant volume. So, we will look at each. Okay. Constant pressure. Apa maksud by constant pressure? The pressure the same lah kan? Okay. So, in a beaker, we have some gases. And now you guys are injecting this with inert gases. Okay. Masuk ke inert gases dalam ni. Okay. So, at constant pressure, so the system try to keep constant pressure. So, what will happen is, yes, volume dia increase. So, we will have net effect of lower the total pressure because volume dia increase. Sebab kita nak keep the same pressure dekat the original gases. Okay. So, the same thing yang kita tengok is moles of gas. Okay, kita add inert gas, the total gas pressure decrease. So this is the one yang I said you have to do a bit of thinking. Okay, because the reason now we are looking at, okay, it makes sense kalau kita tambah gas dalam, the pressure increase kan? Kenapa the total pressure decrease? Okay, you have to remember that this is a completely frictional beaker. Okay, to keep at constant pressure, this beaker boleh membesar atau mengecil. So when you add, untuk pressure dia keep constant, okay, the beaker can jadi larger, okay, or is it bigger? Okay, bigger. Okay, that's how the only way kita nak keep the constant pressure. Okay, so when the beaker is larger, to keep the constant pressure tu, the gas pressure yang the original gas pressure akan decrease. So that's why kita akan move to the left. Why? Sebab kita nak more moles of gas. Okay, boleh kan? Alright. So this is just a different way kalau belah kiri yang sikit, belah kanan pula yang besar. Okay, it's just vice versa. You are looking at the moles of gas. So remember, stoichiometric coefficient. Okay. So this is the same explanation. Okay, I'm fast forward because it's the same explanation. It's just doing for each of the chemical reaction lah. You're still talking about the same thing. Okay. So this is just a different punya variation je. Okay. So now, okay, based on Dalton's partial pressure law, we can find partial pressure from this equation kan? Hari tu kita tengok. Okay, partial pressure is equal N A R T over V. Okay. So, but now, what happen bila kita change temperature, dia punya temperature? Okay. Can anyone describe, saya ingat saya punya beaker. Can anyone describe me what happen kalau kita contohnya change the temperature, heat the temperature, heat the beaker? What happened to the molecules? They move faster because they ada higher kinetic energy kan? Okay. So it will move faster because it has higher kinetic energy. Okay. In second semester, you will belajar on rate of reaction, where kita akan explain more on this phenomenon. Okay. So, the general idea, lagi tinggi kinetic energy, lagi keraplah dia akan berlaga with each other. Okay, so dia akan langgar each other. So the collision is called collision theory. Korang belajar dalam physics tu? So the more it langgar, right? Ya ke? 0.5 ada, right? The more it langgar, that is kita cakap when it will react, kan? So it will react when dia langgar each other. It makes sense. Kalau dia tak langgar, macam dia nak react? Kalau korang tak berjumpa, macam mana korang nak bercinta, kan? Kan? Siapa dah minta nombor dah? Ada ke? Senyum je. Okay. Alright. So, untuk change in temperature, we have to know a few things here. Okay. Untuk kalau soalan yang tanya pasal change in temperature, you will always have delta H. Okay. What is delta H? Delta H is for now is heat energy lah. Okay. And we will always have negative ataupun kadang dia tak tulis negatif. So kalau tak tulis negatif is automatically positive lah. So what is positive and negative? Okay, negatif dia cakap exothermic. What is exothermic? Exothermic, I mean it release energy. Okay. Release energy. And endothermic, it means it absorb energy. Absorb energy, right? So, untuk delta H, okay, when you punya equilibrium punya reaction, given bagi delta H, the delta H is for forward reaction only. So take note, delta H is for forward reaction. So forward reaction punya delta H, okay, which is the reaction of PCl3 and chlorine gas bertukar ke PCl5. That is the delta H. So maksudnya bila PCl3 bercampur dengan chlorine gas menjadi PCl5, those process akan release heat. How much heat? Is 111 kilojoules. Okay. And luckily, to make things easy, is it will mean that bila PCl5 menjadi balik gas chlorine ataupun then PCl3 punya gas, dia akan absorb energy. Make sense? Right? Nak bercampur, dia lepas energy. Okay. And then bila dia nak berpecah balik, dia akan absorb energy untuk berpecah balik. Okay? So that's why dia akan absorb this much. So kalau dia bagi delta H dia is for forward reaction, and for the reverse reaction, so this is reverse reaction, you just tukar plus jadi minus. It's the same energy. Alright? So is that clear? Okay. Temperature is special. Okay. In equilibrium. Okay. Contohlah kita tambah energy, kita tambah temperature in the system. Okay. What happened is, okay, the forward reaction is exothermic. So, okay, bayangkan korang dalam bilik ni, saya naikkan temperature aircon. Okay, sekarang pun korang dah berkipas panas. So, apa yang korang buat? Kalau saya dah naikkan temperature aircon dah panas, korang nak jadi lagi makin panas ke ataupun korang jadi sejuk? Yes, jadi sejuk kan? So, the same thing akan jadi dalam our reaction. Dia orang nak sejuk. So, kalau dia bertukar ke PCl5, which release energy, dia makin lagi panas, dia orang nak ke? Tak kan? Kalau boleh, dia nak buang energi yang ada lebih tu. So, what will happen, untuk kurangkan balik temperature tu, the PCl5 akan bertukar balik menjadi Cl2 and PCl3, sebab the reaction is endothermic. It absorb energy. You bagi dia energy, dia absorb energy tu untuk kurangkan balik temperature. Alright? So, sorry endo, kalau korang betul kan? So, endothermic reaction is favorable. Okay. So, it remove the heat from the system. So, likewise, kalau kita tambah heat, so it's the same thing, tukar je. Sekejap Okay. So, like this, it is exothermic because lepas end of the reaction, they give the delta H negative. So, you tahu negative exo. Exo buang tenaga, which is panas. Okay, macam you guys buat okay, eksperimen 2 hari tu. You guys tak buat lah, tapi kalau you guys buat betul, kalau pernah buat dekat sekolah dulu, you campur acid dengan base. That's also exothermic. Kalau you perasan, lepas you titrate, you pegang yang beaker conical flask bawah tu, dia akan rasa panas. That is exothermic. Dia release energy. Okay. So, the only special thing yang you need to take note, kan tadi kita ada four main factors yang kita ubah kan. Kita ada ubah concentration, kita ada ubah pressure and volume, and now kita ubah temperature. Okay. The only thing yang akan ubah equilibrium constant is temperature. Okay, you ubah temperature, you akan ubah equilibrium constant. Okay, untuk other factors, untuk concentration, untuk volume, untuk catalyst, you will only ubah dia punya equilibrium, kiri atau kanan, itu je. Untuk temperature, you akan ubah the equilibrium constant itself. So maksudnya equilibrium tu akan berubah. So it can be lagi cepat ataupun lagi lambat. Okay. So what happened dekat equilibrium? Based on the graph, at which point the equilibrium occurs? Dia punya concentration sama ke? Concentration product and concentration reactant sama ke? Ataupun rate of tukar concentration, rate of tukar sama ke? Apa yang sama? Apa yang sama? So remember, the equilibrium point is where the concentration dah stay constant. Tak semestinya this is product, this is reactant. Tak semestinya this concentration sama. Tak. It means that bila concentration dah tak berubah, that is equilibrium. Okay? So, bila you ubah temperature, the time taken, okay, the time taken untuk dia stay constant mungkin berubah. Maybe dia jadi dekat sini, or maybe you akan ubah dia dekat sini. Hence, we also will ubah the nilai K. Okay, the equilibrium constant also akan berubah. So, how so dia berubah? Temperature kita increase. Okay, contoh in this case, kita increase temperature. So, temperature increase, dia nak jadi lagi panas ke dia nak jadi lagi sejuk? Nak jadi lagi sejuk, so the reaction will go to the left. So, we will have more more reactant, sorry. So, more reactant, hence, Kc bertambah ke berkurang? So, Kc akan berkurang. Right? So, vice versa. Kalau temperature kita decrease, temperature decrease, dia dah jadi sejuk, dia nak jadi lagi sejuk atau jadi lagi panas? Panas, so temperature akan so dia akan move toward the right. So bila dia move towards the right, so apa yang increase is PCl5, right? So PCl5 increase, Kc akan bertambah atau berkurang? Bertambah, right? So hence why K bertambah and berkurang. Okay, but just remember, only temperature yang akan berubah K. Other than temperature, K tak akan berubah. It will stay the same, right? So this is just an example, right? So this one example of the same thing, it just explained differently. So one thing to dictate you punya answer is, one thing is delta H. Okay, you tengok it is negative, which is exo, and then positive is endo. So endo, endo, tertinggal D. Alright, so delta H yang dia tulis is always for the forward reaction. So maksudnya kalau dia cakap delta H is positive, so the forward reaction is endo, which is jadi cooler. Right? So any heat change, kalau dia jadi lagi sejuk, dia mestilah dia nak patah balik. Right? Kalau dia jadi panas, dia nak pergi ke depan, dia nak jadi sejuk balik. Okay, boleh faham? Right? So this is just an example. And lastly, let's look on catalyst. Okay, the last factor. We only have 4 factors yang kita akan cakap. Concentration, volume or pressure, and then temperature and catalyst. Alright. Catalyst, you guys pernah belajar sekolah menengah kan? So, catalyst buat apa? Yes. It increase the rate of reaction, tapi they are not consumed kan. Okay, so you pernah nampak this kind of energy diagram? So remember tak ini apa? Yes, activation energy, EA. Hilang. Terkejut saya. Okay, so EA. So don't worry, second semester baru kita akan masuk on activation energy semua tu. But now just know that catalyst only reduce activation energy. Okay, the lower the energy, lagi banyaklah you punya reactant jadi product, right? So catalyst will never change the value of K. Okay, so catalyst dia tak ada effect on equilibrium position. Okay, so untuk equilibrium, untuk catalyst, we only have, it is just changing the rate. Okay, equilibrium tak berubah. Okay, so sometimes soalan akan tanya pasal catalyst juga, just to trick you. Dia fikir oh the reaction berubah, the reaction will shift kiri ke kanan, right? So it will not change anything. Okay, boleh ke? So this is the general note untuk this Chatelier principles. Okay, we have 3. We have campur catalyst lah. Okay, so the only outliers here is the temperature sebab they change the value of K. Okay. Kalau you tengok this concentration change, right? Pressure and volume also they relatively almost change the concentration. Okay, kenapa dia tak change value of K tetapi temperature berubah? Okay, anyone have any idea kenapa temperature ubah the value of K? Okay, kalau based on this graph, okay, so this is reactant, this is product. Okay, so why temperature, the only thing yang ubah value of K is when kita increase the temperature, tadi korang dah jawab, kita increase dia punya kinetic energy, right? So it has more collision. Okay, same thing kalau here, sini, we are calling this EA, right? Activation energy. Siapa ingat apa maksud activation energy tu?
Jalan shortcut.
Yes. Energy, the important keyword is required. Energy required untuk reactor ni jadi produk, right? Kalau dia duduk saja, dia tak bertukar suka hati. So when we supply more energy, we are physically pushing more reactant over the barrier to become a product. Hence why the value of K berubah, because we are physically moving the reactants towards dia punya product. Others, we are just changing dia punya equilibrium. Okay, because kalau others, they change the equilibrium, dia akan patah balik jadi normal balik. Okay, dia macam seesaw. Okay, kalau boleh dia nak sama balik. Tambah berat belah mana, dia nak jadi sama balik. Okay, I think that's it for today. And tomorrow korang K2, K3 kan? So tomorrow kita akan bincang sikit pasal I will do revision on UPS 2. Okay, but just take note that the soalan yang saya bincang takkan keluar dalam UPS 2 lah. Saya akan bincang the concept. Alright, okay, so that's it. Nanti kita akan sambung the Haber process. Okey, untuk dalam yang online, tolong masuk ke dalam Google pula, dalam Discord.